Hello, today I want to talk about our update on sprint4. We built some model on sprint3 to distinguish the inhale from exhale in the sound of breath. And now we are going to improve the accuracy of such model. And we're also trying to visualize this model for our audience to understand what we did. So first, we want to pre-process the data. Our first technique is to remove the noise, which would make the data more cleaner. And then we use the neural network to analyze the results. The CNN just doesn't work, so we turns out to use FFNN, which results in an accuracy a little bit worse than guessing. And finally, this is our visualization. You can see that the inhale should be more than exhale. However, the result is inversed. Like our predicted result is inversed. Then we try to make the data much more cleaner. So we remove the silence part. Now here is the data. You can see that there are a little bit more inhale than exhale, but they are equally the same, roughly the same. After analyzing the data, we find out that for each piece of data, there are 300 features, which is crazy. Therefore, we want to reduce the dimensions down to 3 for the sake of visualization. And after we did PCA to reduce the dimensions, we can visualize the data here. Then we use the K-mean, which is one of the supervised learning model to separate the data into two clusters, the blue one and the green one. And we measure the accuracy by two techniques. They all point to the same results, which is our model is a little bit better than guessing. Then we also use the DB scan. Here is the visualization, and our score is still a little bit better than guessing. We also tried the supervised learning. There are two models, extreme gradient boosting and random forests. For each one, we tried a lot of different chunk of data. Like we have our total data file is about 2 hours, and we divided the files into small pieces. Each piece may be from 50 milliseconds to 600 milliseconds. And we just tried every possible data. And finally, we find the best accuracy happens at 200 for random forests. And the accuracy is 0.56, a little bit better than guessing. Here's the visualization of that part. You can see it predicts some inhale, some exhale or inhale. Finally, I want to conclude our sprint4. As you can see, we didn't reach a very good accuracy. However, there are some reason behind that. The first is because the efficient data sets, like our total data set is only in 2 hours, and we cut the noise and the silence parts, which make it much smaller, maybe just 30 minutes or 1 hour. That is too small for such a big project. Secondly, it's even hard for human to distinguish the inhale from exhale. Like for example, maybe you think it's inhale when you listen at first time, and if you listen again, it turns out to be it sounds like exhale. Also there are some shortage of our model because we remove the noise and silence. Our model cannot reflect the real world situation because there are a lot of noise and silence in the real world. That is one shortage of our projects. That's all. Thank you.